Okay. Can everybody hear me?
Yep.
Okay. I'm talking now. Okay, so I replaced my modem this week. So hopefully some of that choppiness that was occurring before will stop. 1 second. So today we are going to be discussing stacks. So your first programming assignment should be visible, right? Let's make sure it's unlocked and everything's good. Okay, which one is this? This is today, I think. Nope. It's I think this is section 1531, right? Zoom. Yeah, okay. So you have an engagement this week, and you also have your first project that was posted. So the project, which I already have over here, give me a minute, I will pull it into view. So this is your first programming project for this course. So it's worth 100 points. The objectives are to apply the knowledge of the comparable interface to a problem, to understand and override the string and equals methods. Okay, so there is information on this interface in the book. This interface already exists, so you should not be trying to recreate it. The book describes it and discusses what the comparable interface has in it, but Java already provides this. Okay, so please don't try to re-implement it or re-implement it and then use that interface, your own personal interface named comparable, because it already exists. So you can look it up and find out information about it. So Java comparable interface, see, already exists. It tells you that it's in java.lang. So that means that you don't even have to do any imports for it to work. Okay, it just tells you information about it. You can find, I'm sure, even outside the book, I'm sure you can find examples of its usage. This is a pretty decent site. Java Point tends to be on point, except for the indentation issues, but that's another story. But you do, when you implement the comparable interface, what you are promising to do is to implement this method right here, compare to. So whatever data type we're comparing with, it'll be that type right there, whatever matches this. So you decide, what does it mean to compare two different, in our case, employees? Okay, so if one employee is greater than the other employee or has more experience, or sometimes it's based on degree, I'll explain that in a minute. If the employees are equal, you return 0. If the employee calling this, so if I say emp1 dot compare to emp2, when I actually call it, emp1 is the calling employee or the calling object. So if that one is greater than the one passed in as an argument, you return 1. And if the one calling the compare to method is less than, whatever that means, the other employee, then you return -1. Now I'm going to fill in the whatever that means part. Okay, so For this assignment, you will create an employee class. To maintain consistency for my grading, please place your employee and employee demo classes, both of them Java files, obviously, in a package called proj1. So that means that don't call your package P1, proj1 with a capital, my project, prog1, snuggles, dump truck, buffalo, or my employees are awesome. Call the package proj1. So that class, the employee class, will contain the demo classes, obviously the one that will have the main method in it that you can test your employee out in, or employees, I guess. But the regular old employee class has different fields. It has a degree of type degree type, which is also a type you have to make, right? Also, it'll have a first name of type string, the given name of the employee, such as Amanda, and last name, the family name of the employees, such as Hug and Kiss. So experience, an integer representing the number of years that the employee has been with the company. Okay, and the class will basically, one of the methods will actually determine based on the degree and experience what the value points for this employee is. So the class needs to have the following methods. So you'll have two different constructors, right? And I'll tell you what you're supposed to be doing in these. And this one right here initializes the fields to the corresponding values passed in by the client. I do recommend using this keyword to overcome name shadowing instead of coming up with brand new names for all of these. But I guess it is a better stylistic choice, in my opinion. Getter and setter methods for each of the field names. And then, as mentioned earlier, you should override the equals and the toString methods that you get from object. And it tells you what these things should do. And then the compare to method, you're comparing yourself to the other employee. And it tells you what values. Oh, it says current shipped. That's not right. Sorry. I think there was a copy pasta issue. It should say current employee objects. So -1 means the current employee object's value points is less than the other employee value points. Okay, so the degree points that go towards the calculation look like this. So no degree is 1, associate degree is 2, bachelor's degree is 3, master's degree is 4, doctorate is 5. Okay, and then the way they calculate it is you take your experience in years times the degree value. Okay, in other words, a person with 5 years with a bachelor's degree would be the 5 years of experience, and bachelor's degree is oh, that's not right. That should be 2, shouldn't it? 3. Oh, this is sad. So I should probably redo this. Okay, let's fix this as we go along, and I'll just replace it because there's just too many errors at this point. I must have changed a condition and just not looked at it carefully enough when I did the examples. Okay, so but a 5 years person, that's the experience years, times the degree value, that would be 15. And also, since I'm up here, I'm going to say current employee in both cases here. I guess in this case, it's just using the general term. Okay, and we've got that fixed. So I'm going to actually save this and update it. Sorry about that, folks. Oh, that's right. I've already got it open. So I got to close it and then try.
There's one more thing.
Uh-oh, yeah. What'd you find?
Just after where you changed the 5 times 3 to 15, there's another 2 times 5.
Did I? Wait a minute. Okay, it's worth the same as a person. Oh, I see. Yeah, okay. Working 3 years. Okay, I see what's going on. Okay, let me see if there's anything else. Oh, make sure you call it proj1, by the way. Okay, so let me save this and I will update it, because it's usually one error. I'll let it slide, but that's too many. That could confuse people, especially those that didn't join us today. Okay, let me just fix it real quick, just so no one. It's weird because I'll read through these things and it never dawns on me something's wrong with them until I'm reading it out loud to you guys. It's really funny. Okay. Let me see here.
It was a logic error.
It definitely was. Yes. Brain no worky. Okay. All right. That's fixed. Okay. So that one's fixed. That's bothering me though. It should be in a category. Projects. Got it. Name it A's for everyone. Yes. No, don't do that. That'll cause serious problems, especially with the apostrophe. All right. So that should be fixed. Apologies on that. The back to the project real quick here. That we fixed it. The toString and equals do pretty much what you expect. The equals method is based on the value points. Excuse me. You can use an internal method, like if you make a private method that just calculates the number of value points, so you don't have to recalculate it in equals and then compare to and all this other stuff. You can do that if you want, but it would make more sense to make that type of method private because no one outside should need to have to worry about what the value points are. It's just they need to know, is this employee equal to the other, or how do these stack up? So again, create your project, make sure the package to package the employee and the employee demo in a package called proj1 and nothing else. Okay, so turn in a zipped up folder containing just the Java files. I don't need the .class files. Okay, I'm going to say it again. Everyone pay close attention. I don't need the .class files. I need the .java files. Okay, sometimes I use the term generally and say, make sure you send me your classes or send me the files with classes in them, or I might even accidentally say class files. Yes, class files are required. Got it. Yes, exactly. So I do get a ton of people turning in the .class files instead of the .java files. These are the files that run through the Java virtual machine. These contain the bytecode. I can't. Well, I mean, I can actually reverse engineer them and see some of what you did, but I can't see all your comments and everything you did with your variable names and style and everything unless you turn in the Java source files. That's all I need. Those are found in any of basically the Apache NetBeans projects. So if I have a Apache NetBeans project right here, for example, bag ADT. Oh, no, those are videos. Sorry. Why did a video end up in there? That's where that thing went. Okay, so in here, do you see how I have in NetBeans, I have the source folder underneath the particular project folder. In here, you'll see the Java file or files, okay, that I want you to copy, put it in some sort of just folder that you create somewhere else, copy, paste it, and then zip up the folder, okay? Please put it in a folder, though. Don't just zip up just the file. Okay, is there any preference to the way to do it? Should we use something from bag or chains, or does it matter? This particular assignment, no, this one doesn't actually have to. I don't think I specify whether you have to use an array-based or a link-based approach. I would say just using an array-based approach, or even not even having like a collection of them, just like creating 2 or 3 instances of them and comparing them in main is fine. This one is just to make sure that everyone's kind of up to snuff on their fundamental class abilities and that you can implement interfaces, that you can work with an enum and fields, and that you know how to create constructors, that you know how to override toString and equals. The compare to method is the method you're overriding or implementing from the comparable interface. But there's really not any data structure stuff in this. This is more me working with your general data type knowledge and also making sure you understand the algorithms that I'm describing correctly. Okay. All right, are there any questions about this? Any further questions about the project? You might come up with more, as time goes on, that's fine too.
Do you want us to throw exceptions in like the main file when we take input? Or does it need to have user input?
No, it doesn't need to have user input. Actually, I'd prefer it not have user input personally. It just
Okay.
makes it easy. It makes it easier to test. But
so we could just throw in a few test objects or something.
Yeah, and just make sure you can show. Okay, you might even. I mean, I don't care if you even use examples like I had down here, like create one employee with 5 years experience and a bachelor's degree and another employee with 3 years of experience and a doctorate, right? So if that makes sense. So is that good? Any other questions?
Yeah, I see the due date's March 4th. Can we get feedback before that?
If you have, this is usually how I work with feedback, because my general rule is I'm not going to grade it 2 or 3 times. But I will, if you have specific questions, like this doesn't look right to me, because A, B, and C, or how do you do this? Or is this the kind of output you're looking for? Something like that might be appropriate. But just to like arbitrarily send me it with no context, unless you have any kind of specific questions, because part of this course and part of the courses you're in are too. Just for a practical reasons, it's better if I have information from you about what your concerns are, but in the learning aspect, it actually helps everyone kind of work more towards articulating what they're discussing and articulating the code and what's being described and what's expected, and trying to make the two, come together. But yeah, no, I don't mind giving feedback, but not just like an arbitrary throw it at me and let me pseudo grade it 2 or 3 times before I actually grade it. That's not that I don't usually play that. So okay, does it make sense? Yeah, okay. But I don't mind answering questions at all. I mean, any questions during class, after class, email, it doesn't matter. I try to get to them as much as possible. Okay, any other questions about this project? I know I tend to be long-winded, but I want to fill in gaps that people might be thinking about. So just to make sure. Okay, if you don't have any more questions at this time, we will go right into the material. So
Just
this
quickly,
week,
was there a rubric in there?
There's not a direct rubric, except for the fact that I have listed the different things you have to have implemented.
Okay.
So it's kind of bullet pointed, and you can assume, okay, I have to have all these fields. If I miss one of the fields, then obviously that's points off. But I haven't put like, this is worth 1 point, that's worth 3 points, and I didn't itemize it that well. But it's you can assume if you've got all the fundamental properties of it, or at least the majority, then you would get the majority of the points.
Okay, yeah, I was just thinking of like, we learned algorithm efficiency and didn't know if we were going to be implementing stuff like that.
This isn't. Okay. I mean, unless it's something just completely absurd, like the if you remember the algorithm C or B, I mean, the algorithm B that we looked at for summing numbers, unless you just like pretty much go out of your way to write an inefficient algorithm or something like that, I couldn't see myself taking points off of this particular one, because that's not really the intention of this. It's just to make sure you're kind of up to snuff with the review material that we went through during the first couple weeks, and like what I would consider 1500 or even like some 2151-ish type material that we reviewed right here, or introduced for the first time, whichever one. So just Java stuff. Is that good?
Yeah, thank you.
Okay, no problem. So stacks, we'll start with stacks on, that's chapter 5. Right here, some familiar stacks. So this is an abstract data type, just like the bag. Okay, but it has different rules involved with it. Some things might be similar, some things might be completely different. So with stacks, you might have a stack of books, or a stack of bowls, or a stack of gifts, right? You can add an item at the top of the stack, and you remove the item that is topmost. We're assuming people aren't doing you know, anything funky like grabbing the book here and then pulling it out, like trying to be like Harry Houdini without the rest of the books falling. Okay, the idea behind the actual Stack ADT is that you can only access the item at the top. If I put a new item onto it, I can put it at the top of the stack and it becomes the new top of the stack. The thing that used to be the top of the stack is now under that. And to get to it, I would have to remove what's currently at the top. So we call this a LIFO, or last in, first out. Sometimes you'll see FILO, but it's usually LIFO. A last in, first out data structure or abstract data type. So here are the specifications of the ADT stack. One of the cool things they do in the book is they give kind of a pseudocode, but then they'll say, okay, build on top of that a little bit. And then this would be like UML syntax. And then they give a description on what it's supposed to do. So it's kind of nice. So the terms we use for adding and removing elements in a stack are called push and pop respectively. Push is adding an item to the stack, and pop means to remove an item from the stack. I can tell this would have been excellent when making blackjack in a game project. Yes. Yes, that probably would have been useful. Yes. So push, new entry, pop, the element. So when you push an item, you have the item passed in. We're saying it's of type T because we don't know what the type is. This is going to be like a type parameter. It's a placeholder essentially. And the purpose of push in this implementation, the one we're going to work with and that we're going to see, is that it doesn't return any value. It's void. So it could return a Boolean representing, you know, if you were able to push onto the stack successfully, or it could return a number or an integer rather, indicating something else. It could be anything like that. But it doesn't have to. And in this case, they chose not to have it return a value. So this adds a new entry to the top of the stack. The input is new entry is the new entry that's been added. And the output, there's no output, okay? No return value. That's what they mean by output in this context. The pop method does not take any arguments. It takes no parameters, so it does not have to be told what to remove. It knows to only remove the top entry. It returns type T, so that means a reference to the entry at the top of the stack. We also have methods called peek, is empty, and clear. Is empty and clear probably are self-explanatory, but peek is basically retrieving the stack's top entry, the reference, without changing the stack in any way. So it's kind of like pop, but it doesn't remove the item from the stack. It just tells you this is what this thing does. Pop removes it and gives you the reference to it. Peek just gives you a reference to it. Is empty does what it pretty much tells you. A lot of methods, if they start with is or are, like ARER, they return a Boolean because they're telling you something about the abstract data type. So in this case, is empty returns a Boolean, and it detects whether the stack is empty or not. There's no input to it. It doesn't need it. And it returns true if the stack is empty. It returns false otherwise. Clear performs the operation of cleaning out all the entries from the stack. So it removes all the entries from the stack. So there's a design decision that has to go in when you're making these stacks. One of the things you have to decide on is when the stack is empty, what do you want to do, or what do you do with pop and peek? So for example, if you try to peek in an empty stack, there's nothing there to tell you, you know, what it is. And if you try to remove an item off of an empty stack, that's also a problem, right? So we have to come up with some sort of action. So the possible actions are assume that the ADT is not empty. You know what they say about assuming. Return null, or throw an exception. And then if you throw an exception, you have to decide which type. Okay, so with the information we have from earlier with the specification of like the UML and the pseudocode and the description, this is actually not a bad format to go through if you're designing a class on your own, whether it's a data structure or just some other data type that you're trying to implement. It is actually a good thing to look through and try to say, well, we'll need this, we'll need that, we'll need that. So the pseudocode is kind of your quick jotting down of what kind of data needs to be passed in, what kind of stuff might need to come out. Maybe I don't know yet. And then you put it in like a UML format and then come up with a description, or you can come up with the pseudocode and description and then come up with UML. Either way. But once you have the UML, you can actually, the closest thing Java gets to code that looks like the UML is actually in an interface. And remember the difference between an interface and an abstract class. Remember, ain't got no body. An abstract method ain't got no body. And interfaces only have abstract methods. Abstract classes can have abstract methods, ain't got no body, or they can have implemented concrete methods that do have implementations. But we're right now worried about this interface. This interface is just saying, what should something that claims it's a stack be able to do? That's all the question this thing is answering. What should an entity, a class that claims that it is a stack, be able to do? And the methods that we're providing in this case are push, which this pretty much came directly from the UML, right? Void is its return type, and then it takes a T new entry. And that's pretty much exactly what we had up here, right? A new entry of type T, and it returns void, and it's public. So the UML gives us all the information we need pretty much to create the interface. So we got the push, and then we have like a description of what it does. The public right here returns a T, and its name is pop. Okay, peak, same thing. We also, you'll notice that it says that they throw an empty stack exception if the stack is empty before the operation. Okay, so we also have, again, peak is empty clear. And here's an example. If you think of A, B, C, D, as it goes from left to right, as time is moving on and things are happening. So a stack of strings after push adds gem. That's what this stack looks like after push adds gem at, we'll say, time A. Later on, if push adds Jess, Jess becomes the new top and gem is no longer the top. There's no way to get to gem unless you remove Jess first. Okay, that's the key with the stack. If you try to access an element down here or somewhere in the stack that is not at the top, or insert anywhere an element anywhere but the top, then that violates the stack abstract data type. You go to part C, you can add Jill by pushing Jill onto the stack. And again, they're showing it as the string is right here, but it's really a reference, but this is just for a visual. And then they added Joe. Now, things start happening differently when at part or time F, it says pop retrieves and removes Joe. So Joe was on the top of the stack. When you call pop on this stack, it returns Joe because he was the top. Then who's the next top? Jane becomes the top after Joe is removed. Then if we do another pop, it removes Jane. And then when Jane is gone, Jill becomes the new top, and so on. Any questions so far? Okay, so security note, design guidelines, use preconditions and postconditions to document assumptions. Do not trust client to use the public methods correctly. Avoid ambiguous return values and prefer throwing exceptions instead of returning values to signal problems. Since we have exceptions at our disposal in Java, it makes more sense to use them. Some languages like C, the original C language, not C++, but C, do not have exceptions. So you have to do things like return values to signal problems. Preconditions and postconditions, in case you are curious. The preconditions are just your assumptions about what should be the state of affairs or what's going on in the program or in the lifetime of the program before you enter a particular method. And then post conditions are your assumptions after. Meaning if that method changed something internally, your post condition, one of them might be, well, it changed the age field in, so maybe it's set age. Your preconditions are an age variable exists and the user passes in a value greater than 0. And then the post condition might be the age is changed, the internal age is changed to whatever the user passed in. Processing algebraic expressions. So infix is each binary operator appears between its operands. So this will end up, you'll see it is kind of related to stacks in some ways. Some of the stuff I'll have you do will not involve you having to use a stack directly, and some stuff will involve you using a stack. So right here, though, infix is the notation we use most of the time. Prefix notation, on the other hand, is another notation that means the same thing. For example, you would prefix the operator and then followed by its 2 operands, okay? So instead of it being between them, it's in front of them. And then postfix is when it's after them. So balanced expressions, the delimiters are paired correctly, okay? So this still means A plus B in prefix, and this still means A plus B in postfix. And this, of course, is the one we're familiar with. This means A plus B in infix. So this involves delimiters and finding sides on things. Once we go through this, hopefully it'll make a little more sense. But the contents of a stack during the scan of an expression that contains, say, balanced delimiters, whenever you encounter an opening curly brace or bracket or parenthesis, you push it onto the stack, okay? But then when you start encountering closed items like this, you should pop stuff off of the stack. So basically what happened is when you encounter this, these are the delimiters in the expression. When you encounter a closing parenthesis, the thing you should be reading on the top of the stack should be a parenthesis because it was innermost. And then you pop it, and then you're left with this as the top of the stack. And that means, well, it's an opening curly bracket is what I should be popping off because I'm reading a closed square bracket. Since I'm reading a square bracket, I should be popping off a square bracket. And then the same thing with the curly braces. And then this is actually a technique similar to this is actually what the compiler does to determine if the braces, curly braces, brackets, and parentheses match in your program. So that's how it knows real quickly if you don't have matching curly braces or matching for your functions or matching parentheses when you make function calls, method calls or method. I'm sorry, I teach a C++ course on Monday and then I teach this course on Tuesday. So I'm constantly switching between function and method. But in Java, we call all the functional units methods. So processing algebraic expressions, again, delimiters are, if they're not a pair, then this would indicate that there is a mismatch of the delimiters. So that means there's unbalanced delimiters. Okay. Contents of text during the scan, we still have pairs of parentheses, pairs of brackets. So a lot of this stuff, all this stuff should be pairing up eventually. Now, another problem that could happen besides pulling out the wrong, the wrong type of brace, what if we have a curly brace left in the stack when we are completely done reading input? And the answer is that, well, that means that there is a missing closing curly brace, right? Because if you had pushed an opening curly brace and you never popped it, means you didn't come up with the corresponding closed curly brace, then that means that that's what happened, okay? That means that you are missing a closed curly brace. Okay, then they kind of go through like a code work on this and they check the balance of the delimiters with some code examples. This right here is a conversion from infix to postfix. Now they're doing this using a stack. This is not the easiest way for a human to do it, which I'll show you the easier way, but they're converting from the A plus B times C to postfix form. So they line it up like this. Whenever they come encounter an operator, they push it onto the stack. Okay. And then as they keep reading characters, they build it up here and continue doing the same thing there. ABC, okay, keep reading. ABC star. Now what's happening is you're actually, this was the contents of the stack. So the left to right, the right side would be the top of the stack right here. Okay, left to right. So this right here, this star is popped off after you're done reading a letter. And then the plus is popped off and you put it there. There's kind of a nicer way to do it as humans that makes maybe a little more sense to most people, I would think. And it works like this. So if I'm, our whole purpose here is to convert infix notation to postfix notation. And you might think, why is that even useful? Well, there are applications of it. Most of this is an exercise to demonstrate stacks, but there are applications of it. One of them being postfix doesn't require parentheses because none of the expressions are ambiguous. Okay, you don't get the same expression with two different intentions. Whereas with infix, if I have something like A plus B times C, I have to use order of operations, or and then otherwise, if I wanted to do this part first, it's ambiguous, or at least implies ambiguity until I surround it with parentheses. Okay, so let's do a conversion. We'll actually do that. Okay, so A plus B times C. I've got an infix operation here, and I want to use a technique to convert it to postfix. Now you could use the stack technique that they use in the on the slides there, and then in the book. They also, I think they probably tell you the other, what's they call the I don't know if it was this book or some other book, or it might be multiple books that call it the pencil and paper technique, because this is actually kind of nice too. To convert it, the first thing you do is you start adding parentheses, even if they're not necessary. So what happens is I put them around the first thing to be done, right? That's the first thing we would do, right? Is the B times C. So I put parentheses around it. Then I put parentheses around the second thing to be done. Okay. And then within each of their sets of parentheses, I move the operator to the end of that set of parentheses. For example, this plus right here is with the A inside of this outer set of parentheses. I put the plus at the end. Inside this inner set of parentheses, I put the star at the end because that's the set of parentheses it lives in. And now all you have to do once you've done that is you delete the parentheses, and that's the postfix expression right there. Okay. So let's see if this actually holds weight. Now I'm going to show you a technique for calculating a postfix expression properly. So let's assume A is 10, B is 5, and C is 2. That good? So that means that I'm looking at the prefix versus postfix. So I have prefix, or I'm sorry, infix versus postfix. I said that wrong. Infix versus postfix. A plus B equals C is 10 plus 5 times 2. So that should equal what?
20.
20, right? Because we do the multiplication first, and then we do the addition after that. Now, my postfix version is 10 space 5 space 2 space star space plus. Okay, that doesn't look quite as doable. It seems like that would be really difficult, but you can use a stack to actually calculate postfix. So with the conversion, I recommend just using the pencil and paper technique like this. But for the actual calculating of let's calculate a postfix given a postfix, you don't have to convert it to an infix in order to calculate it. We have a stack right here. And let's say that here's the rules. Anytime you come across a number, you push it onto the stack. Anytime you come across an operator, like times or plus or what have you, you pop the last two off of the stack and apply the operator and then push the result back onto the stack. So for example, I'm reading a 10, so that means I push a 10, right? I'm reading a 5, so that means I push a 5 onto the stack, right? Then I read a 2, so that means I push a 2 onto the stack. Now what happens is I come to a multiplication symbol. I do not push that onto the stack. What I do is I pop the second item on, or the first item that I encounter, and then the second item becomes the first in the expression. And you look at them as if they're having that applied to them. If it were infix, it would look like this. So 5 times 2 is what? 10, right? So you take that result, 10, and you push it onto the stack. Okay, so I popped those two off, multiplied them, and then pushed the result back onto the stack. Now, this isn't a number either. This is an operator. So that means I pop the last two one by one. This one becomes the first operand. If it were infix, this one becomes the second operand. Then I apply the operator. So it's 10 plus 10. That gives me the result 20. So then I push that onto the stack. Now, if done properly, that means that now I'm at the end of reading the string, and the solution should be the only item left in the stack. And it is. It's a 20. So that's correct. So let's do it. Let's do another one. Does anyone need to take a screenshot of this before I delete it? If you need to take a screenshot, please do. Okay. All right, so I'm going to give you a little practice. I want you to, the first one, we'll do them piecewise. So I'm going to have you convert this. Let me see here. What do I want to do? Convert this infix. Convert this infix expression to postfix. So your problem is convert infix to postfix. Okay, convert the infix to postfix of this right here. Okay, so I'm going to move that up in the corner a little bit, and I'll give you a few minutes to work on that. So I guess before we well, no, I guess we'll just do the conversion right now. So let's do the conversion, then we'll worry about calculation in a second. So converting this to from infix to postfix, what do you think the first step we're going to do is? Putting parentheses around which ones? What's the first thing you would do?
Multiplication and the division.
Yeah, yes, of course, because which one would you do? Which one in practice would you do in this specific problem first? Which one would you do?
10 times 2.
10 times 2. So I'm gonna put 10 times 2 plus 6 divided by 3, right? And then you scan over it again, and you find that you're going to put a set of parentheses around the 6 divided by 3, right? So then you're going to put a set of parentheses around this kind of whole thing here.
Yeah.
All right. And now what do? We move the multiplication symbol here, the addition symbol to the end of that set of parentheses, and the division symbol, oops, there. And then we can just take away all the parentheses. Okay. All right. So this is what we're claiming the postfix version of that infix is, right? So let's calculate the infix first, and then we're going to actually put this to the test and determine if we're correct. So using Stack, calculate the postfix thing here, right? Just make sure. First, we're going to do the infix version just to make sure we've got the right solution. So this is going to be 5, and this part's going to be 2. So 5 plus 2 is 7, right? So we should end up with a 7. Is that right? Check my math.
Yeah, that's right.
Okay, because there's too much advanced math in my head, so all the other stuff falls out.
So after dividing, should we have plus?
Oh yeah, I must have deleted it somehow. Sorry about that. Yeah, that should have a plus at the end. My apologies. I'm going to grab that and fix it. Yeah, I just noticed your comment as you came in here. Okay, so that should be our friend here. So so we should get 7. So take if we look at it, we've got a stack here, right? And let's see if this turns out right. So if we push, if we push or encounter a number like 10, we push it onto the stack, and then encounter another number and push that onto the stack. Now we're encountering what? We're encountering an operator. So what do?
Pull those 2 back out and multiply them.
Yes. So make this one the second operand and that one the first one. In this case, it doesn't matter, but for division, it will. So that is important. And then we're going to push back onto the stack a 20, right? Now I encounter a 6. So I push that onto the stack. I encounter a 3. So I push that onto the stack. And now I encounter a division problem. So what do? Oh, this isn't, I don't think this is going to end up right. I think I goofed somewhere, but let's see what happens. Okay, so 6 divided by 3, right? So you're going to get a 2, and then that's 22. That's not right. Okay, I think I know what happened. I think I know what happened. It was when we were doing the conversion. That was my fault. Okay, so okay, let's try this again. 10 times 2 plus 6 divided by 3. Okay, so this part was correct. All right, that's correct. But now the 6 divided by 3 part should be done later, right? So let me see here. So that, okay, because this, you can even put another set if you need it, but we're saying that we do this first and then something else in here second, And then the other one, we would do third. That doesn't seem right. That's the same problem we had before, isn't it? Oh, shiznit.
Why you think it's not right?
You gave us a 22, didn't it?
But it should be 22, no?
Shouldn't it be? Wait a minute. What did I do? 2. Oh, 22. What the hell? Why did I write a 7? Why is this over here? That was from. Never mind, guys. Sorry. I'm too much Benadryl. Okay. So 10 times 10 times 2 plus 6 divided by 3. My allergies are really bad today. So, okay. So 10 times, I don't know, Mom. I think he was stoned. Okay. 10 times 2. I'm not actually stoned. I'm just little sniffles. Okay. So that was correct the way we did it. Correct. Okay. So we'll move the plus to the end. We did end up with the correct thing. So we moved the divide to the end here. And then we ended up with the multiplication to the end here. Got rid of all likely story. Exactly. Got rid of all the parentheses, and that was our friend. Okay, sorry. Pretend that whole fiasco didn't happen, and we're working on this now. So what happened is we left off where we had pushed a 10, then pushed a 2, then multiplied, and now we're putting those back on the stack. Okay. Then you push a 6 and a 3, and then you see the division symbol, right? So when I see the division symbol, I pop, but I put that one as the second operand. The first thing you pop is the second operand always. Okay, so then I get 6 divided by 3 rather than 3 divided by 6. Okay. I take this and I get a 2, right? So I'll be really, really cheap here. Okay. And you get the 2 there. Now it says I have to add them. So I pop this one, put them on that side, right side, and then the other one, I pop that and put that on the left side, being the left operand. And then I push the result of those 2, which ends up as a 22. Okay. All right.
Can I ask a question? Probably
Sure.
Pretty stupid here.
No, it's not dumb. It's fine.
What is the actual application of using these stacks and with algebraic equations?
Some of what we're doing is just to get you used to using stacks, but there are calculators. I had a professor. He's since retired, but I had a professor at U of M that actually used a postfix calculator all the time. You don't need parentheses. So you'll find out that even if the original thing you get in infix has parentheses in it, the resultant postfix actually does not have parentheses in it. So it's just, in some ways, it's a way to expand your math knowledge, and it's so that you can and expand your way of thinking and your problem solving skills. And it is actually used in some settings where if, for example, memory is really tight, so each character has to be encoded, each character or each value has to be encoded. So if we have no parentheses, we don't have to worry about encoding. Now I know that seems like kind of an extreme case, but that is one of the things that does happen as a result of being able to use postfix. You basically just kind of space them out, or they already have built-in spaces in them, so you don't actually have to encode the space, and you enter the values and the operators in order to come up with the solution. So this is probably not something you're going to apply immediately to a website thinking, oh, this is really cool or whatever, but these are just different ways people have come to understand how to write down calculations. And we tend to think the infix notation is the only way to go, but that is not necessarily the case. Yulia.
So I have a question. Why we cannot put all of these operands like inside of the stack and then just to know what is after everything? I mean, why we have to summarize by hands 2 parts?
What are you talking about?
So we put there 22, but why we cannot put just 10, 2, sine 6, 3 plus and put all together and it will summarize by itself? I mean, why we have to separate all these operations? So we put
well, it has to do with the rules that you're going to apply and to ensure that the order is correct of the actual operations occurring. Because if you just let's say you just went this direction, you pushed everything onto the stack, and let's say you were able to push these onto the stack, it might end up ambiguous where what the plus applies to, because that'll be the top of the stack at the end, right? So do you apply it to the 3 and the 6? That's not what it should be, right? So you have to have like a running total going on as you go and encounter these. You update the new values on the stack, because if you don't do that, you're going to end up with an ambiguous or incorrect solution.
I see. Thank you.
Brianna, did you have a question? No? Okay. So so that's that one. If anyone needs a screenshot, please take it now. I'll give you a second to do that.
Just I guess not an observation more than a question. Is this kind of a way to save memory on the stack? Instead of holding, like, if infix, you have to hold all of those things in memory and then resolve them.
Yeah, it could be seen as that, but I think the more important part of the whole thing is the way the stack operates, and the fact that a stack ends up putting things in reverse order as you add them. So you will find that stacks are very useful for certain circumstances. One of them that we'll come up with is like if I wanted to print a linked chain backwards. If I ask you to print an array backwards to file, all you would have to do is start at the last index and work your way back, right? Right?
Yes.
With an array. Okay, so I have a bunch of elements in this array in each of these spots, and I would just basically tell you, okay, well, you just have to start here and then print them backwards. But we don't have that in a linked chain. So let's say it's a singly linked chain, and I have oops, that's not what I wanted. Let's say it's a singly linked chain, a chain with a links facing in only one direction. And I ask you, you know what, actually that's that's probably too much. That's fine though. Okay, so these are all linked to each other, but I ask you to, let's say I have a 5, an 8, a 3, and a 1. So if I ask you to print the elements in order, it's pretty easy. You create a walker right here and you say, okay, print the 5, get next, get next, get next. But there's no get previous. The only way to add a get previous would be if we linked it the other way and started and had another field to represent the end of the list. And that means each node now has, instead of twice as much, reference data that it needs to keep track of, it's got 3 times as much. So you might ask the question, is there any other way that we could print these values backwards? And one solution is to use a stack. If I want just the values printed backwards, let's say ultimately they're obviously going to have a reference in them in what we're using. But let's say that ultimately we're just pushing the value. We're not worrying about the node. So you're going to push a 5, push an 8 as you encounter them, because we have to go in order. That's the only order we can go into. Push a 3 and push a 1. And then once you've done that, then you can just pop the elements off the stack and put them in that order. So you're going to end up with 1, 3, 8, and 5. Right? So I've successfully printed these out in reverse order, even though my memory I was working with was initially only pointing in one direction. So that's actually a brilliant way to use a stack to do a reverse on something. They're also good for detecting palindromes, for detecting closing and curly braces matching, like we mentioned before. They're used in compilers extensively when people develop compilers. As far as directly using this math, I don't know that many people are going to directly appropriate postfix, but there are some systems that do, partially because it does save on the tons of parentheses, and it's unambiguous without parentheses. So that's kind of a nice feature. Okay, anyone need a screenshot? If you want to take a screenshot before I delete this. Okay, going once.
Will converting infix to postfix be something like on the midterm?
Yes.
Yeah.
Okay. Yes. So anyone else need a picture of it? Okay, going once, going twice. Sold. Okay, so the midterm is the 8th. Okay, so we've got a while before then, but yeah, that will definitely be on the midterm. Probably even, it might even be on the final since it's cumulative. It may be one of the things I pull in, because it's not crazy difficult once you're used to it, and it looks it's kind of cool, and it's kind of a brain exercises and algorithmic activity. So I'm going to give you a convert infix to postfix notation. And I'm going to give you this one. Let me see here. Don't calculate it yet. Let me see here. 2 3 plus 10. Okay. This one's a little bit trickier because it's got a set of parentheses in it, but I think you'll figure out fairly quickly what you need to do. If anything, hint, hint. Okay, so 6 plus 2. And then once you've done that, use stack to calculate postfix result. Verify that the infix value is the same. Okay. All right. So there you go. Those are your two little things to work on for right now. And I will give you a few minutes, and then we'll look at it together, but it gives you some practice time. Okay. It was about 4 or 5 minutes, I think. Does anyone want a little more time to work on it? We can do a couple more minutes if anyone needs time. But if not, we can start on it. I can't read the crowd the same way that I can do if it's an in-person class. So
I'm ready to go.
okay. So converting infix to postfix. So this first one right here, the really cool thing about this first part here is that they've already put the parenthesis here for us. So we don't really do anything. What's the second thing you would perform? Would it be the multiplication or the addition?
Multiplication.
The multiplication. So you take whatever the result of that thing in the parentheses and do a multiplication. And then finally, you would do this addition, right? Okay. So now, what do? I put the operator at the end of the set of parentheses in which it is being applied. Okay. Right. And then remove all of the parentheses because we don't need parentheses in the postfix notation. So there's our solution. Does that look good? Anyone get something different or think they goofed or think I goofed?
That looks good. Okay,
good. Yeah. I already paid my dues with all my degrees, so I get to make mistakes. You guys can't. Right here, if we put this right here and we do the actual calculation, how are we going to come up with or what kind of solution are we going to come up with? Let's see what happens. Right here, we have the 6 that we encounter, right? We encounter a 6 and push it. We encounter a 2 and push it, right? Then you encounter an operator. So we add those two in the order 6 plus 2, but it wouldn't matter in this case. But 6 plus 2 is 8. So I push the result, the 8, back onto the stack. Then that, guys, we're done with that part. We do the 3. So we push the 3 on there. Now what happens? I multiply 8 by 3 and I get 24. Is that correct? Yes? Yes. Okay. 24. And then I encounter a 10, which I push onto the stack. And then I pop and pop, add 24 to 10. I get 34, push it onto the stack, and I'm at the end of the string that I'm reading. So the input tape or the input string. And my answer is 34. Let's verify it against the solution here. So what do we have here? So we have 6 plus 2, that's 8, times 3 is 24, plus 10 is 34. So that's the correct solution. Good. Everyone get the gist of this? I'm not gonna throw anyone for a loop and do any exponents, because that actually adds some more complexity that we're not gonna mess with. Okay, but this is the best. This is a really good technique for doing the conversions between the two. If you want to test yourself, you should also note that if we have another one over here where we remove the parentheses, this becomes a different problem, right? Now we know by the order of operations, this is going to be 6. You're going to end up with 12 plus 10 is 22, right? But the way that the operations work in this one is you would end up, okay, so you have 6 plus 2 times 3 plus 10. Once we start converting to a postfix, you know, we would do this one first. We would probably do that one second, right? And then this one at the end third because it's left to right. And then we can move this, and you move this to the end of that set and that to the end of that set, and we delete all the parentheses. And okay, and you'll notice even without parentheses, this is not ambiguous. This is not the same thing, right? See, no parentheses, but it comes up with a different solution, just the way the infix one does, but neither of these need parentheses to be unambiguous, right? Don't need to worry about order of operations, just use the stack. Good. Once you have the postfix, obviously. Are there any questions about this? Anyone need a screenshot? I'll leave it for a second for you to take a screenshot if you want. Is that good? Are there any questions? Do you need another example right now? Or I might do one if anyone asks closer to the time to do the midterm or whatever. If we need to review, we can do that. But for right now, does it seem pretty comfortable?
Yes.
It's decent.
Yeah.
Okay. Okay, good. All right. So, well, actually, I'll leave this one open in case we need it. Okay. So, successive operators. Okay, they're doing like they also go in how to do the powers and stuff like that, but we're not going to worry about that right now. Let me see here. Some of this you don't need to memorize like the whole algorithms and stuff. They're just showing different instances in which stacks could be used in kind of an interesting way. Already did that. Already showed you how to. So the two major things you need to do is convert infix to postfix and be able to evaluate postfix expressions. Those are the two major things. Okay. Converting infix to postfix and evaluating a postfix expression, meaning coming up with the solution once you have. Oh, you could also add modulus in there, by the way. Modulus is up for grabs as well, obviously. But anyway, you just need those two things. Okay, so so we wouldn't have to go over all those slides. I just figured we'll do examples instead. Now, the program stack is something you definitely need to be aware of. You probably have heard an instructor at some point, I hope by this point, you've heard an instructor at some point say something along the lines of, oh, well, that variable is declared and the memory for it lives on the stack. You may or may not have, I don't know, but there's the two major areas of memory that we generally work with are the program stack, or what we call the runtime stack, and the heap, okay, or it's also called the free store. The heap is where variables go if you create a new variable dynamically, or a new object dynamically. So if I say something like rectangle R equals new rectangle, as soon as I say new rectangle, the new operator is a unary operator, takes its operand, the constructor of the object it's constructing, reserves the memory for it, and then returns the address of that new memory. Okay, so that's on the heap. That is not organized as a stack, but the program stack is. When you call methods, when a Java program starts, the first thing pushed onto the stack is main, or rather what's called an activation record or a stack frame. Okay, so an activation record or stack frame, those are the two different names for this data structure that, or well, data type that is pushed onto the program stack. Okay, so, and main has something called the program counter. You don't need to really memorize that part, but main and all the methods have something called the program counter, which actually labels an address of the instruction. So if we're at instruction 1, or the address of instruction 1 is obviously not a real realistic number. It would be much longer, but these are just for demonstrating, obviously. But what would happen here is we have that, and we have list of arguments, and then any other local variables, the X and the Y, for example, the actual variables themselves will be stored here. But as soon as you get to this line right here, where it calls method A from inside of main, method A's activation record or stack frame gets pushed onto the stack, the program stack. And then it has to maintain, well, what line is it on? and what values is it setting. So this is method A, blah, 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 blah. Into A, maybe A gets set to some other value. A is 5 at this point because I passed in the argument X. It makes a copy of it. So A is set to a copy of whatever you passed in. In this case, since it's a primitive, it's one of the primitives, an int, it means that A takes on the value that was passed in, which is a 5. So locally, this variable has its own copy of 5, right? Inside here, it makes another local variable, which would be inside the activation record somewhere. It's not demonstrated here, but it is there. And then Z sets Z to 2, and then it calls what? Method B. Okay, method B gets called into memory, ... It sets B to 2 because what was passed in? Well, method A called method B and passed its own local variable Z in, but what value does it have? A 2, right? So that 2 gets passed in as an argument, and then method B takes on that value, it copies that 2 into its local variable, its parameter B, and then uses it from then on. And then as soon as the methods are done, let's say method B completes, method B will get popped off of the stack, and then method A will continue doing its stuff, and then it gets ready to return Z, and it pops off the stack. And then main starts doing its stuff, and it gets its result from, it's called a method A. And then when it's completely done doing all of its stuff, it pops off the stack. And then when main pops off the stack, your program terminates. Okay, so this is another invaluable, very important use of the Stack ADT. Okay. Something to be aware of is there is actually a Stack class available through Java that you could use this one instead of coming up with your own, but they're just, we go through the process so that we know how to make one in case we need to make a custom data structure at some point or custom data types at some point. That's why we go through these exercises. The other thing is to understand them better and know what they're good at and what maybe they're not as good at, what they're more efficient with and what they're not efficient with, what data representations are available. So the Java class library has this class stack in java.util. So import java.util.stack, and you would be able to just create stacks and then call push pop peek empty. Instead of is empty, they called it just empty. It tells you whether it's empty or not. The push and the pop are very, very similar. I'm sorry, the pop and the peek are very, very similar. Push, their version of push, the one in the Java library, returns a value of the data of the old top, I think it is. So if you're pushing on top of, say, let's say you're pushing these are going to be addresses, but let's say that you're pushing a 5 on top of a 10, it'll actually return a 10 as it makes 5 the new king of the hill, right? It makes it the top of the stack. But that was a stylistic choice that they made. Our version in here, the one that the Henry and Carano developed, the people that wrote the book, that one has a void type. So there can be little modifications and differences between implementations. It's definitely a possibility. And as we see here, it's a likelihood that we get different implementations. Okay, we will talk about implementations in just a little, but see, that's the end of that one. Stack implementations, we will, let's read this slide and then it'll have your head spinning while then we'll go on break. So each operation involves top of the stack. So if we want a linked implementation, we should be able to make a linked implementation. And also, what's the alternative to the linked implementation? The array-based implementation, right? So if we do a linked implementation, each operation involves top of the stack, push, pop, and peek. Head of the linked list would be the easiest and fastest thing to access. So you can just decide, it's not really arbitrary, but you decide that it is the top of the stack. So even though to us, it might look like a chain of linked nodes, right, that are all connected, you might decide that this is just a visual, obviously. So we could actually consider this the top. And anytime we push, we just need to add a new one, make this one's next point here and make the top point to the new one, break that link. Anytime we need to remove one, it removes only the top of the stack. So what's it going to do? It's going to jump over basically the current top and then that thing will get garbage collected, right? So that's basically what that thing's going to do. If we, we're going to move on in just a second, but we'll decide like what makes sense to make the top of the stack, or why would we choose it to do this, and is this going to be different from our array-based implementation, in what ways? So we're going to talk about that when we get back from a short break. So let's say 7:43. So that gives you a little bit of time. Be back at 7:43. Go on break. So you can go, as always, bang your head on the wall, take a nap, cry in the corner for a couple minutes, eat a sandwich. All right. I'll be back in just a little bit. Be back at 7:43. Alrighty. To be fair, I did say you guys had to be here back at 7:43, not me. Okay. So the linked implementation, if we look at this as one of the alternative implementations, looking at this as the top node, as the first in the chain, and then any subsequent node would represent the nodes below the top node on the stack. So you can see that as humans, we really like visualizations, but in the grand scheme of things, it doesn't matter if this is at a diagonal or upside down or in a circle. It doesn't really matter. We're just using this as a model to represent what's going on in reality, so, or virtual reality, whichever you prefer. So the top node is right here, and that node has its data pointing to the top entry of the stack, and then the next field points to the next node in the chain. That one points, of course, for its data field to the data below, just below the top, and then it points to the next node in the chain, and so on. Now they're giving information about how would we make a linked representation of the stack interface. So we have a top node. When you create an empty stack in the constructor, all you have to do is set the top node to null. Okay, so that indicates that we have an empty stack. You'll notice it does have in this implementation, a private class node inside here with data and next. And then there are other methods, et cetera, which we'll look at. So for a linked implementation, a new node that references the node at the top of the stack. So if we are adding a brand new node to the stack, we have to add it at the top. Now, in a linked implementation, the top is currently this node, but we're going to have a new top in just a minute. It will be this brand new node that we're adding. So we link it in here, and then the top node is going to point to this brand new node, making it the new top of the stack. Push, this right here creates an instance of the node with the new entry and its next set to top node. If this is the very first time we've ever called push, then the top node variable, because of earlier, the top node variable equals null. So that makes perfect sense that that's going to be the next of the element there, the first node that we add. And then subsequently that top node gets updated. And on a different round, let's say we're on the second node added, we create a new node, we set the current top node as the next, and then update who the top node is talking about, right? So what about deleting an element? So if we have these 4 elements in the stack, can I just arbitrarily say, I just want to delete that element and leave the others alone? Or delete this element right here? Can I do that with the stack?
No, you'd have to iterate through the previous entries, or the ones ahead of it, rather.
Yeah, you'd have to, well, not just iterate. Now, as an implementation, obviously, I could do that, but I can't allow it to do that because it's a stack. With a stack, it's first in, first out. So I can't just arbitrarily delete any item I want to. I can only delete the elements at the front. So not only iterate through them, but I have to actually remove that one, and then that one, and then that one in order to get to that one, right? So I have to actually remove them as I go by. This is how you do the deletion. So it always occurs at the top, just like adding nodes. You basically, in Java, you can just basically say, hey, top node, give me your next. And it'll say top node equals top node's next. And it will, then you could return also the data from that node to the client before it gets deleted. But you've bypassed it and it's no longer part of the chain. Therefore, it'll get garbage collected. So this is the removal right here, where currently they're doing an assertion. This will actually just throw an exception if the top node's null, but we could decide to implement an actual full exception situation here if we wanted to. Right here, we have the top equals peak. That actually, that could throw an empty stack exception. Now, if we have top equals peak, that's going to grab the reference to the node at the top of our stack, or the front of our list, if you wish. We assert that the top node is not null, and then we set top node equal to top node's next, and then return that original piece of data that we obtained from the beginning. These are pretty easy. Is empty, you just set, you return whether top node is equal to null or not. If the top node is equal to null, that means that there are no elements in the list. Clear, all you have to do is set the top node equal to null. And what that would do is it would cause a chain reaction because you set the top node equal to null. Let me see here, we're on slide 12, but let's look at one of these. If I set top node, excuse me, if I set top node to null, it's no longer pointing to this first node, which was our top node. So that means this one has nothing referencing it. So it gets garbage collected, which breaks the link here, which causes this to get garbage collected, which breaks the link there, which causes that to get garbage collected, which breaks the link there, and then causes that to get garbage collected. So it has a chain effect. If you were doing something in a different language, you would actually have to go through, like C++ is one of the examples, is you would have to, some languages you would have to go through and like intentionally delete each node as you went along. So you temporarily hold the current nodes next, and then you'd delete or temporarily hold a reference to the current node, the top node, and then you would bypass it. Top node equals top nodes next. You delete current node, which is the one you just grabbed, and then move on to the next one. And you keep doing that until you get to the end. But in Java, all you have to do is set it to null, and the garbage collector takes the rest. So any questions on the link-based implementation of the stack? So the top of the stack is represented by the front of the linked chain, and other than that, it works very much like the linked chain we've worked with before. It's in many ways like the bag, except we just can't arbitrarily access elements anywhere in it. But the actual underlying structure isn't much different. We just control how different it is to access it. We don't allow anyone to touch anything except at the very top. So what do you think would be if we were to go from linked implementation and instead switch gears and talk about an array-based implementation, what do you think that would look like? Like, where would be the easiest place to add and remove elements in an array? The front of the array, the middle, the end? Yeah, the end of the array or the back of the array, right? So that would actually be a lot, that would be a lot better for an array. So it's different than the linked chain. So we're gonna assume that the end of the array is easiest to access because we can constantly, add elements, overwrite that last element, and quote, remove it without having to shift anything over. That's the easiest place, easiest thing to access is the end of the array. So let's make that the top of the stack. Remember, our conception visually of what we normally think of end and front and middle and all this other stuff, this can be manipulated depending on how we control the access to these different pieces of data that make up our data structure. And this is no different. Even though you might look at an array and say, oh, it would look really pretty if the array was vertical and if the top was the front of the array, right? But that doesn't, in actual reality, that doesn't end up being the easiest way to look at it. The easiest way to look at it is just as a regular array, but to realize that the top of the stack is the end of the array. So the first entry you ever add would be the bottom of the stack. So right here, they're actually giving you an example of, well, what would happen if we keep track of bottom index instead of top index? We're just assuming maybe the bottom of the stack is here, and let's assume we add the top of the stack here. And they're saying its first location references the location 0, but that doesn't really end up being a good solution, because what happens if we remove this element? To quote, remove the element and keep thing in the first in last out order, or the last in first out order, we have to shift everything over. So this isn't like the bag where we can just grab the item at the end and fill in the gap. We have to scoot everything over and then like move down by 1. So in this case, we're doing bottom index. We're assuming the top's already always at 0. So it is a possible implementation. It's a valid implementation, but it's just not efficient. Okay. So in other words, you get the correct solutions and the correct behavior. It just would be a lot slower. This is much more manageable. We don't care what's at 0. We don't care what's at 1 or 2. We care what's just been added recently. So keeping track of the top index is just way better. So the first value references, or the first index, would reference the first thing that was ever a top, but now it's the bottom of the stack. And then the last index that we have that's accessible is the top entry of the stack. So we keep track of that top index. So in a linked chain, how did we keep track of the top? What kind of data did we need to keep track of the top? Just the top. Focus on the top here. What was it that held the top node? Any ideas? It was a node reference, right? So it was a reference to a node, and it was the top. In here, we don't have a node reference or even a reference. We just use the index, right? So that's the advantage we get with the arrays. We're just using a little integer. Now, we still have the same problems we'd always have with arrays. We can create our array underlying data structure that is an array to represent the stack, and we'll keep track of top index. They're doing their little security thing that they did before, and also default capacity and max capacity, kind of like we had with the bag. So nothing's really super different here except for this part. When we set top index equal to -1, because if we set it to 0, that means there's a valid element at index 0, right? That means that's the top, okay? But if you put it at -1, that's not a valid index. So we can use that as a special value. So what do you think, without even going to the slide, what do you think the code, it's going to be one line of code. What do you think the line of code is going to look like for is empty for the array-based implementation? Bueller?
I mean, couldn't you just check the element at index 0? And if it's null, then there's, I don't know, maybe not.
We're not even guaranteeing that we're going to set it to null. I suppose we could, but maybe null's even a valid value. We don't know about that implementation, but I mean, it's even simpler than that, and it has to do with something you can see here.
So if top index is -1.
Yeah. So every time we add an element, we're going to increment top index and then put the element at that index, and then it'll keep growing. But every time we pop an element off of the stack, it's going to keep reducing. And when we pop the element at 0 and do top index minus minus, it's going to take it back to -1 too. So whether it's at the very beginning or when we have emptied a stack, that's when the stack is empty with an array-based implementation. What we did with the link-based implementation was what? We know that if the top node reference is null, okay, then that means that the stack is empty. But here we're going with indices, right? So we're not necessarily in here guaranteed that the data, because we don't have a data portion and a next portion, we just have the data. So we can't necessarily be guaranteed that the data is going to be null. We might choose that that's not a valid value, but we could store null at a particular cell if we wanted to. What does push look like? Again, we're updating it slightly. So we've got the, would be a version that can actually expand the size up to a particular maximum. But we've got check initialization. That's their little security thing we're not going to worry about. Ensure capacity would make sure that we have enough room to add an element to the next location. So we put stack at top index +1 equals new entry. And then you increment the top index to indicate that we now have a new element. So if we're at the very beginning or the stack is empty for some other reason, top index equals -1. -1 + 1 is 0. So that will put stack at 0, our little array behind the scenes, equal to whatever this new entry is. Ensure capacity. This is not too shocking. This is very similar or nearly identical to the thing that we had with the bag, the dynamic array implementation for the bag. So top index, if that's the stack length minus 1, in other words, if the array is full, we double its size. Okay, so we double the size here, check the capacity, make sure, set stacks, stack equal to arrays.copy of the stack and the new length. Okay, so we copy all the elements over. Peak, we test, is it empty? If it's empty, we throw an empty stack exception. Otherwise, if it's not empty, we know that the top index is valid. So that means we can just return the data stack at top index. Any questions so far?
Nope.
Nope. Okay. So we've got the array-based stack after its top entry had been removed. All we would have to do is just decrease top index, and then you could return the reference that's at 3. Now, optionally, which was mentioned before, you could put a null there, and that would actually, cut this reference so it wouldn't have like 2 references to it, or just a reference just sitting there wasting space, or you could just leave it there. If you do put null there like they're doing here, then that would mean that you return it to the client. But if the client doesn't grab it or doesn't care to hold on to the reference to it, then what happens? There's no reference count, and that means that the garbage collector will be able to come by, go num num num, and return the memory for other uses. Okay, of this actual data. The data occupied by this will just contain a null at that point. So pop looks like this. So if we're empty and you try to pop, it will throw a new empty stack exception. Otherwise, we grab the top, okay? We set the top index equal to null, and then we decrease the top index to indicate that that's no longer part of it. But then you also return the top in case they wanted to hold on to just the data portion in some other data structure. It could be another stack. You might want to throw it in a bag. You might want to just process it and get rid of it. It doesn't matter. Okay, so this is what they're calling it, vector-based implementation. This is an object that behaves like a high-level array. Index begins with 0, methods to access or set entries, and size will grow as needed. We could use the vectors methods to manipulate the stack. So you could, if you already have a data structure to work with, like this vector here, which is already a dynamic array that's implemented for you. Java even has one. It's kind of old school, but it has one. But it is perfectly acceptable to use. So we could use this vector that's already does a lot of the work for us, and it already resizes as we need it to. So we could use this and then treat it like a vector underneath. So what we're doing here is we would be creating a client using the methods given in the stack interface, and those methods interact with the vector underlying, and then the client will actually interact using that particular interface to just the stack. So the vector itself would not be able to call, or would not be calling elements, or rather calling methods that don't behave in a stack-like manner. Like, hey, I want you to delete the element at index 4. That's not stack-like behavior, right? Stacks only allow access at the top. So you can actually use the vector, but restrict its access to it through this interface right here. So this is actually available. This is a vector type. This is available. It has constructors, has methods to add, remove, and clear. Also methods to determine last element is the vector empty number of elements, etc. So they created a vector stack implementing the stack interface. They're using a vector underneath. This is not a type that we came up with, or although it could be, but let me see here. So Java vector, this is the type they're using. It's java.util.vector appears to be what they're using. Now they're using an E here for the element type, but we're using a T in ours, but it's the same thing. You could put sausages there and it doesn't really care. But that's a common type holder. Okay. So you have vector of type, vector of T, whatever T ends up being, a stack of those things. So this is a vector that we named stack instead of a regular array. And in this case, what they're doing, checking capacity, they create the instance of the stack. And then when we do something like push, we just call the vector method add, and that adds it to the front of the vector. And the way we're going to view it as is the top of the stack. To peek, again, we could throw an exception and we could just say, hey, vector, you know what you're doing. Give me the last element. The last element being the top, okay, that we're going to be accessing on the vector. For pop, we just have to tell it, hey, remove the last element. So remove the element at stack size -1. That's where I want you to remove it. So what we're really doing here, if you'll notice, stack is empty. Stack is empty is actually a method that already exists on vector. So where'd it go? So is empty already exists on this type. So all we're doing is basically delegating to it to tell it what to do. And we don't have to do hardly any work, right? We do very little work. We literally just do, we would call this like a pass-through method. It just basically calls another method to do its bidding. And then clears it, right? No magic there. What we're doing here, what you see here is actually some kind of variation on what is called the adapter design pattern. They're taking the vector, which does everything we need to get the stack to work, and they're just changing or restricting access to it and adapting it for our uses. So this is adapting it, because you'll notice a lot of these are just pretty much one-liners, and there's not much work that push has to do. Now, if you had to look at the code that the vector implemented, this would be a lot more complicated than one line, right? It would have to do all the work we did earlier, pretty much with the array, at least. Same thing with peek, get the last element. Same thing with remove, remove the element at the stack size -1 and is empty and clear. But this one, the vector itself, named stack as the underlying data structure, is the one actually doing the work. So if that in that case, we call that typically an adapter, the adapter design pattern. All right, any questions about any of this, or anything you feel is pertinent to discuss? This class goes way longer when I do it in person. I think it's because all of you are quiet or taking naps and not interacting as much. Yeah, did you have a question, Tom?
No, I was just gonna say, when we use the T, that's a to be determined data type, right?
Yes, it's called a generic. Yeah, it's
okay,
a generic
just to remind
type.
myself.
So, right, what actually happens behind the scenes when you have this T here, it's not actually a data type yet, but later on, if someone says creates a vector stack of type, let's say in your code you have, I want to make a vector stack of strings called my stack or whatever, and then equals new, blah blah blah, vector stack. What that does is the compiler then knows when it compiles, it has to create a version. It takes basically all your code and it basically creates a new class called, vector stack or st vector stack or string vector stack or whatever, or vector stack behind the scenes, and then puts string in here wherever it occurs, wherever it encounters a T. Okay, so likewise, vector is a generic. So it actually, when the string gets filled in here, it'll fill in string there and create a version of vector that handles strings. So it's not really magic, but it's really, really cool things that are going on there. If you make another vector stack of type rectangle, then you're going to end up with a stack of rectangles. It's going to actually create a version of your code where instead of T here, anywhere you see T, you actually, if you look at the bytecode, you would see rectangle at that point. So it saves a whole lot of time being able to use generics, because you don't have to implement the same thing over 27 times or do a bunch of copy and paste or anything. So generics save us a ton of time. If you're in my C++ course also, that's those are called templates. They do approximately the same thing. Yes, Tom, I think.
It's just better to think of it as a placeholder.
Yeah, it's basically a placeholder. Yeah. Bueller, any questions? No questions. Should I Should I like just tell dad jokes for an hour just to make it feel like we've extended the class long enough? Or no? Okay. Doesn't look like everyone's into that. All right. So any questions before we I guess call it a day? We got through that a lot faster than I was anticipating. Any questions? No. Okay. You're dismissed. If you have any questions for me about the project or about anything else, just send me an email and I'll try to answer it as best as possible. If you have code questions, please send me code. I would actually recommend you send me the code file attached, not just copy pasta into the copy paste into the email body, because that makes it a little more difficult. But if you send me the file, that often, unless it's like 2 lines and you're like, what does this do? That's fine. But if it's like a big, I can't figure out why this thing's crashing, and then you paste 400 lines of code into the body of the email, I will come haunt you when I'm dead. Okay. So any other questions? No questions? Okay, I'll stick around here for a little bit. Other than that, you're dismissed. But if you have any questions you need to ask me afterwards, that's fine too. I'm going to end the recording here. So